All right. Can we start?
Please go on. We can start now.
All right. So we're all welcome to our class for today. This is statistics for economists, and this is our first class. So, Faiza, are you there with us?
Yes,
Yes, I am.
How about Mr. Toila?
yes, no problem.
All right, Halima, are you there with us?
Yeah, I'm here. Can you put your slide on presenter view, please? So that we can all see the screen clearly.
Okay.
Thank you.
All right. So let's go on. So today in our class, we'll be looking at statistics, data, and statistical thinking. That's introduction to statistics, data, and statistical thinking. So instructors for today will be I, Anzaku, Jacob, and Abdulrazak Alima. So this is our outline. First, we're going to look at what is statistics, the use of, of statistics in economics and other social sciences, descriptive and inferential statistics, a quick glimpse at statistical inference, and then finally, we'll be looking at that data set. So, what is statistics? I would like us to know that this class will be very interactive, and then we should feel free to give in all the contributions that we can and to ask all the necessary questions. So, I and Alima will be anchoring the class for today. All right. So, what is statistics? Now, in common usage, people think of statistics as numerical data. every time you hear of statistics, what comes to your mind that it is okay, Ame, I can see your hands up.
Yeah, please, can you help us put it on presentation mode so that it will be bolder than this, please? Thank you.
Okay.
If it's on PowerPoint, F5 should display.
Ross, I mean, help us with the voice. All right, hello.
I can hear you.
Yeah, I think it's not working here at my end. So uh, I'll send the material after the class. So let's.
Sorry, it's your desktop. It's your presentation in PowerPoint on your desktop.
Yes, it's on PowerPoint.
And the F5 is not displaying it.
Okay, F5.
Yes, click on F5 on that
Okay.
PowerPoint. You should press straight to come to presentation.
All right. Is it clear now?
Yes, it is
Yeah, yeah,
clear.
yeah. That's it.
All right. So let's go on.
All right.
Now, let me come again. We said in our class today, we'll be starting introduction to statistics, data, and statistical thinking. I'm sure we must have gone through on the learning system all the course outline. So for our first class for today, we'll be starting this lesson one under statistics for economics. So this is our outline. What is statistics? The use of statistics in economics and other social sciences. Descriptive and inferential statistics. We will also take a quick glimpse at statistical inference. And then finally, we'll look at data sets. All right. So what is statistics? Now, commonly, when people use statistics, they think of it as just a numerical data, which is correct. E.g., when we say the employment rate last year, we always think of it as a particular numerical data. Also, when we look at total government expenditure for last year, we also look at it as a numerical data. And also, the crime rates of city, for instance, we can count them and say, okay, this is a numerical data. A numerical data is a data that is countable. Now, but we'll be looking at statistics deeper than just a numerical data. So, what is statistics? Our definition here says statistics is a methodology for collecting, classifying, summarizing, organizing, presenting, analyzing, and interpreting numerical information. So which means statistics is more than just a numerical data. We'll look at it as a methodology. So as we go on, we will come across a lot of other things that will give us more important information and how we can apply statistics in economics and in business. Now, the use of statistics is in economics and other social sciences. Now, businesses use statistical methodology and thinking to make decisions on how to run their operations, which may include products, how much to spend on advertising them, how to evaluate their employees' performance, managing inventories, and so on and so forth. Now, here, our approach to statistics will concentrate on its uses in the study of economics. You will also learn business uses of statistics because many of the exercises that will be used will focus on business problems. Now, views and understandings of how things work, especially in economics, are usually called theories. Now, economic theories are descriptions and interpretations of how the economic system functions. Now, let's consider these economic theories or statements. Now, people usually say people maximize utility, or we can hear demand curves slope downward. We can also hear the rich are getting richer and the poor poorer. Also, we can hear things like Nigeria is a wonderful country, etc. But these are propositions which may or may not be testable. Uh, by that, I mean that we may test them and we may not be able to test them. For instance, if we say Nigeria is a wonderful country, what do we mean by that? Under whose observation are we saying that Nigeria is a wonderful country? Can we conclude that it is a wonderful country? So, what usually help us to be able to make all these conclusions is statistics. So, statistics is the methodology that we use to confront theories like that of demand and other testable propositions with the facts. It is the set of procedures and intellectual processes by which we decide whether or not to accept a theory as true or false. The process by which we decide what and what not to believe. In this sense, statistics is at the root of all human knowledge. So statistics, being the set of analytical tools used to test theories, is thus an essential part of scientific process. So we see the importance of statistics. If we want to test all these economic theories, we can only use statistics, the methodology of statistics, to be able to test these theories and to be able to ascertain and draw out conclusions and inferences. So what is descriptive and inferential statistics? Now, the application of statistical thinking involves two sets of processes, which is the descriptive and the inferential statistics. Descriptive, in the sense that it utilizes a numerical and graphical method to find patterns in the data, to summarize the information it reveals, and to present that information in a meaningful way. It means that a descriptive statistics use numerical data to describe and say, okay, this is how this data is. This is the pattern in which it follows. Maybe we are looking at the number of uh, customers who buy a certain product. Let's say a day, people who buy bread, maybe 10, and then maybe people who buy uh, milk, 5. So we can use descriptive statistics to be able to show the pattern that the data follows. Differential statistics, on the other hand, uses data to make estimates, decisions, predictions, or other generalizations about the environment from which the data were obtained. Now, example of tools in statistics that we use for descriptive statistics may involve pie chart, mean, median, and so on. Whereas that of inferential statistics, we may use things like the chi-square, the t-test, some other non-parametric statistical tools. Now, a quick glimpse at statistical inference. Now, statistical inference, remember we said we are looking at inferential statistics. Now, statistical inference essentially involves the attempt to acquire information about a population or process by analyzing a sample of elements from that population or process. So we have a population, and then from that population, we take a sample. Because reason being, we cannot use all the population in the experiment, because which means we have to waste, or it will involve more resources, it will take more time, and then so on and so forth. So that is why it is important to take a sample from a whole population. Now, a population includes the set of units, usually people, objects, transactions, or events, which we are interested in learning about. For instance, we could be interested in the effects of schooling on earnings in later in life, which means we want to know whether, if you have gone to school and you have a BSc or an MSc or a PhD, will it tell how much you can earn after the degree? So, in which case, the relevant population will be all the people working. That's if we want to take the effect of schooling on earnings later in life. Or we could be interested in how people will vote in the next, let's say, gubernatorial election. In that case, the relevant population will be the registered voters in that particular state that we are looking at. Now, we have explained a population. A sample is a subset of the units comprising a finite or infinite population. So, which means a sample can be countable or not countable. Now, because it is costly to examine most finite populations of interest and impossible to examine the entire outcome of a process, statisticians use samples from populations and processes to make inferences about their characteristics. just like I explained earlier on, since it is usually always impossible to examine the total population. So we take a sample out of the population, and from that sample, we can make an inference about a particular characteristics of the whole population. Now, it is important to note that the manner in which a sample is selected from a population is extremely important. Take for instance, if we want to know who which who will actually win a particular gubernatorial election, and we place, let's say, two contestants side by side, and most probably maybe we use a particular manner of collecting data online, maybe using WhatsApp or social media. It may be that those who are voting are not even on social media. So if we are going to make an inference based on just people who are on social media, we may end up discovering that people who may come vote are not even on social media, so we'll be wrong. So that is why it is very, very important that the manner in which we take a sample from the population should be carefully done. Now, when we make inferences about the characteristics of a finite or infinite population based on a sample, we need some measure of reliability of our method of inference. So we need to ensure that it is reliable before we can make those inference. Now, data sets. Now, we can think of data sets. Here we say generally there are three kinds of data sets, which is the cross-sectional data, time series data, and panel data. Uh, the time series data is the data collected over time. Over time, let's say we want to measure the amount of rainfall that fall from, let's say, 1990 to the year 2020. That's an example of a time series data. But as we go deep into the course, we will get more understanding on what a cross-sectional data is, uh, what a time series data is, and what a panel data is. Uh, for instance, if we go more, maybe like the course that we'll be taking next semester, that's econometrics, we will deal more on time series and panel data. Now, within data sets, there are two kinds of data. We have what we call the quantitative data and the qualitative data. Now, a quantitative data is a data that can be recorded on a natural numerical scale, whereas a qualitative data cannot be measured by a numerical value. So, an example of a quantitative data is, let's say, the gross national product of Nigeria. We can measure that in naira. You see, we can use a numerical scale to measure them, like in billions of naira or billions of naira, and so on and so forth. Also, we can also measure the consumer price index, which is measured in percentage. Now, a qualitative data. Whereas a quantitative data can be measured on a numerical scale, a qualitative data cannot be measured on a natural numerical scale, but can only be classified into one of a group or category. For instance, we cannot measure male or female using a numerical value. We can only use M for male and then female for F for female. Now, an example is a series of records of whether or not the automobile accidents occurring over a given period resulted in criminal charges or not. The entries are simply yes or no, because we cannot measure them using a particular value. We can only measure them by yes or no. So we can say uh, this uh, accident, does it resulted in criminal charges? Then it can either be yes or no. Now let's look at this data on table one, which is the data of the highest college degree of 20 best paid executives. Remember when we were talking about uh, data, we say when we're interested in learning about whether a particular degree determines the earning data in life. So this data was the source was from Forbes, volume 155, number 11, in May 22nd, 1995. That's the source of the data. It's an American data. Now, we can see from the rank from 1 to 10, and we see that we have the rank, degree, rank, and then degree. So this data is from 1 to 20, and then we see we have number one, we have bachelor, which is the highest paid in this particular data. We have two, which is also a bachelor. Three, a doctorate. He has a doctorate degree, and four has no degree, and so on and so forth, up to 20. So this data, by mere looking, uh, we can see that it is purely a qualitative data because there's no numerical value that is quantifying them. Now, table 1.1 presents a purely qualitative data set. It gives the highest degree obtained by the 20 highest paid executives in the United States at a particular time. Now, educational attainment is a qualitative, not a quantitative variable. It falls into one of four categories. Either the person has no degree, or has a bachelor, or a master's, or a doctorate. Now, we can also organize this information in a more meaningful fashion. So, to do that, we will need to construct a summary of the sort that will be shown in table 2. Now, this is table 2, data that we have seen in table 1. Now, this is a more fashionable way of presenting data that we have seen in data. You see, we have the class, we have the highest degree, we have frequency, number of executives, relative frequency, which is the proportion of the total. So, from the data that we had that was much in table 1, we see in table 1 the data was much. But here in table 2, we have summarized the data in a particular way. So here we have those with no degree. We have two of them among the highest paid uh, personnel. Those with bachelor's degree are 9. Those with masters are 5. Those with doctorate are 4. And then which gives us a total of 20. Now the source of our table is table 1.1 above. Now if you look at the proportion here, the total proportion is supposed to give us 1. Yeah, it's supposed to give us 1. So because we are taking like those with no degree, they are 2 out of 20. So when we divide 2 over 20, we get this proportion here, which is 0.1. And then when we divide 9 over 20, we get this proportion here, 0.45. And then same thing with that of those with masters and those with doctorate. And when we sum up all the proportion, we get 1. Now from table 1.2 above, we can observe that a bachelor's degree was the most commonly held final degree, applying in 45% of the cases, followed in order by a master's degree, a doctorate degree, and no degree at all. So this table 1.2 gives us a more clear picture of what the data in table 1.1 is saying. So now we can see that those among the top 20 highest paid executives, those with bachelor degrees are being paid more. Now let's look at table 1.2. Now table 1.3 present wages of company employees in US dollars. So all this the wage is in US dollars. For instance, number one, we have 236 uh, US dollars, 236 US dollars, and it's a female with this particular data. And then if we look at it from 1 to 25, we will see all the information. So, for instance, number 10, if you look at the 10, we see the wage is 191, the gender female, the number in the rank is 35. The wage uh, is 337, and then the gender is male. Now, the data set on wages in a particular firm in table 1.3 contains both quantitative and qualitative data. Unlike table 1.1 that we had only qualitative data, here in table 1.3 we see that we have both qualitative data and quantitative data. The wage is a quantitative data, whereas the gender is a qualitative data. Data are presented for 50 employees numbered from 1 to 50. Each employee represents an element of the data set. For each element, there is an observation containing two data points, which are the individual's weekly wage in US of dollars and the gender of the individual, which is either male or female. Wage and gender are variables defined as characteristics of hello, are we there?
Yes, we can hear you now.
We're
Sorry,
here.
I had a network glitch.
All right.
So data presented are for 50 employees numbered from 1 to 50. Each employee represents an element of the data set. And just like we said, it contains two data points, which is the weekly wage in US of dollars and the gender of the the gender of the observation, which is either male or female. Now, wage and gender are variables, but they are of different sort. They are defined as characteristics of the elements of data set that vary from element to element. Whereas wage is a quantitative variable, gender is a qualitative variable because we can measure the wage, but we cannot. We can measure the wage using a numerical value, but we cannot measure the gender using a numerical value. We can only classify it, and that's why it's a qualitative data. Now, renumbering them starting at 1 from the lowest wage and ending at 50 for the highest wage, the result appears in table 1.4, which we are going to see now. The lowest wage, now yes, table 1.4. So we want to make more money with the data
Oh, yes, sir.
that
Someone's
we
hand is up.
okay. All right, so I can hear you.
Sorry, Bala said his camera is on and is interfering with our presentation.
Okay.
Whose camera is on?
Bala
Bala
said
say, Bala say,
Dandara, the camera is
can you
on.
turn down your camera first?
Okay, thank you so much.
All right. Thank you very much. Can we go on now?
Yes.
All right. Now, the data we presented here in table 1.3, want to see how we can arrange them in such a way that it will make more meaning. So, remembering them starting at 1 from the lowest wage and ending at 50 for the highest wage, the result appears in table 1.4. Table 1.4, which we are going to see down. Now, the lowest wage is $125 per week, and the highest wage is $2,033 per week. Now, the difference between these two, that's the highest wage and the lowest wage, will give us the range. So we see that the range is a measure in statistics we use to get a difference between the highest and the lowest wage. Now, the middle observation in the range is called the median, as we'll see down. When the middle of the range falls in between two observations, as it does in table 1.4, we present we represent the median by the average of the two observations. In this case, the median is $521.50. Now, because half of the observations on the variables are below the median and half are above, the median is called the 50th percentile. I don't know whether I've get that. Now, similarly, we can calculate other percentiles of the variable, like the 90th percentile, the 80th percentile, and so on and so forth. Now, the 90th percentile, uh, below, below the 90th percentile is the 80th percentile, and so on and so forth. So here we can see in table 1.4, we see from 1 to 4, we have the upper quartile, we have um, table 4 from 11 to 16, we have the first lower quartile, which is also the 25th percentile. Now from 23, observation 23 to 29, we have the median, which is the 50th percentile as $521.50. And then from observation 35 to 41, we have 748, which is the third upper quartile or the 75th percentile. And then from 38 downward. Now, the 25th and the 75th percentiles are of interest. These are called the first quartile and the third quartile respectively. The difference between the observations for these quarters, that's $748 minus $340.5, will give us $407.5, which is called the interquartile range. And that is why we say the first quartile and the third quartile are important respectively, because their difference gives us the interquartile range. Now, so the wage variable has a median, a midpoint of 521.50, as we have seen from table 1.4, which is the 50th percentile. We have 521.50. Now, a range of $1,908 and an interquartile range of $407.5, with highest and lowest value being $2,033 and $125 respectively. Now, a quick way of getting a general grasp of the shape of this dataset is to express it graphically as a histogram, and it's done in the bottom panel of figure 1.1. So if you want to get a general grasp of the shape of this dataset, we can express it graphically, just like I explained earlier on using a descriptive statistic, like the histogram that we can see below. It will give us a general grasp of the shape of this data set and tell us some attributes and some characteristics of this data set that we have seen in table 1.2. Now, an obvious matter of interest is whether, let's say we are interested, we want to know, are men paid better than women, or do men receive higher wages or lower wages than women? Now we can address that by sorting the data in table 1.2 into two separate data sets. We will do that for males, and then we'll do one for females. That will give us a headway of knowing which of the gender earns more wages per week. Now, when we do that, we can now find the range, the median, and the interquartile range for the wage variable in each of the data sets and compare them. So once we compare them, we can tell that whether men earn more wages than female, or female earn more wages than male. Now, before we reach the figure 1.1, rather than just present new tables together with the relevant calculations at this point, we can construct histograms for the wage variable in the two separate data sets. These are shown in the top two panels of figure 1.1 that we will see now. Now, Here's figure 1.1. Now it is easy to see from comparing horizontal scales of the top and middle histograms that the wages of women tend to be lower than those paid of men. Now let's take a look at figure 1.1. Now this is figure 1.1. The first figure uh, gives the wage of a female, and then the second figure gives the wage for male. And then the last histogram gives a combined shape of the data. Now we can see from the histogram of weekly wages for male at the top, for female at the middle, and then for all employees at the bottom. Now the horizontal scale is thousands of US of dollars, and then the vertical scale is the frequency. Whereas we see 0, 0.5, 1, 1.5, 2, 2.5. This gives us $0 to $0.5 thousand to $1,000 to $1.5 to $2,000 to $2.5 thousand. Whereas the horizontal scale gives us the frequency uh, of the observation. So comparing with that of the female, which is the second histogram, we see that the highest wage for male here is 2.5 thousand US dollars, whereas that of female here is 1,000 US dollars. And we don't even have much frequency here for those with 1,000 US dollars. So we can see that men tend to earn more wages than female. Now, in summary, we talk about statistics, and then we understood statistics to be just to not just be a numerical value, but we have seen it as a methodology of collecting data, classifying data, organizing data, and analyzing data, and making inferential conclusion. Now, we also look at the use of statistics in economics and other social sciences. We see that uh, some economic theories cannot be fully evaluated without the use of statistics. It is statistical methods that enable us to be able to uh, give inferential conclusions about a particular data that occur. Now, we also talk about the descriptive and the inferential statistics. We see that the descriptive statistics gives us some idea about the characteristics of the data and how we can classify them. Whereas we say the inferential statistics are tools, statistical tools that help us to make inferences and conclusions about various analyses that were concluded. And we say some of those tools include the t-test, the chi-square, and so on and so forth, and some other non-parametric uh, statistical tests. Now, we also take a quick glimpse on statistical inference, and we understood how we can get data from a population. We say from a population because it is impossible to use up all the population. It is more economical to take a sample from a population, and from that sample we can make our inference. And then we say when taking a sample, we should take it, the manner in which we take a sample is very, very important, because if we take samples wrongly, we might end up making a wrong conclusion on the hypothesis that we have sampled. And then we talk about data sets. We see there are three types of data sets. We have the cross-sectional data, the time series data, and the panel data. We see a cross-sectional data involves data from collected at random. We have the time series data collected over a long period of time. We see like the rainfall in a particular vicinity for, let's say, from 1990 to 2010 or so, is the time series data because it is collected over time. And then we also talk about panel data. Now, at the course of this course, when we go deeper, you will see how we can use some statistical tools to analyze this cross-sectional data, time series data, and panel data. Then we also talk about qualitative and quantitative data. We say that a qualitative data is a data that cannot be naturally measured using a numerical scale, whereas a quantitative data, we say they are data that can be measured using a numerical scale. We said that an example of qualitative data is a yes or a no, a male or a female, whereas a quantitative data is a specific value, like the value of, let's say, GDP, given, let's say, in billions of naira, and so on and so forth. Now, we also talk about data presentation, how we can present data, how we can make some meaning out of data. We also understood that the way and manner in which we present a data will actually tell whether it gives a meaningful meaning or not. So it is very, very important that the way we present our data will give us more meaning from a particular data. Now, we also will show how we can use the frequency table to understand more about some of the characteristics of data. I will also show, using the histogram, how uh, we can see a descriptive uh, way of observing data, and so on and so forth. So, as we go deep into the class, today's class is more like an introduction. So, when we go deeper, we'll get to see how we can leverage on some statistical tools in economics, and then we can see when to apply which particular uh, data tool, and then how to go about it, and then we also learn how to use some softwares to be able to make some of this analysis. So that's it from my end. Uh, I'd like to ask Alima, she's my co-instructor, if she has more to say before we can now open the room for questions. Alima, are you there?
Yeah, I'm here. Thank you, Jacob, for the class. It was so insightful. But I don't really have much to add for now. I think we should open the floor for the students. If there's any contribution or if you have any question, so we are here to answer.
All right, thank you, Alima. Uh, so the class is now open for questions. If there are questions, please bring your questions. You can indicate by raising up your hand so we can know, so we can follow them sequentially.
Please, any question or comment?
Are we together?
Yes, we're.
Are there
I
any
think,
questions for today?
eh, Jacob, I want to thank you for the presentation.
Thank you.
So far, it's a productive class and you have been explicit. So, just like maths, we know that as we proceed, when we go into applications, maybe our questions may be more explicit. At the moment,
Okay.
being an introductory class, if we have had some difficult knowledge of statistics, at least maybe that could be the reason why we may be quiet. But
Okay.
as we go into, let's say, doing some applications or doing like that, then I think we could do that. So far, on my own side, what you have presented is fine. Thank you so much.
All right. Thank you very much.
Sure.
If you have any question and you can type in, you can use the message box to type, or you can ask your questions.
All right. So we're supposed to have exercises for the next class, but since this is more like an introduction, I think we can go further to see to look at more datas, more different data. Sorry, not data, more different data. Uh, let's get some example of cross-sectional data, time series data, and panel data. Let's look at their differences and see how we can differentiate between a cross-sectional data, a time series data, and a panel data when we see any of them. I think that will form the basis of part of our discussion for the next class.
All right.
All right. Any more questions?
No, since nobody has answered otherwise, no.
All right. So if that's the case, thank you all for listening. We'll meet in our next class.
Thank you so much.
Have a great day.
Yes.
Hi everyone. Please we want the class to be as interactive as possible. We are all free. If you have questions, you can reach out to the instructors. If you're on the WhatsApp group, you can reach out. We're always here to answer your questions. And please, for the exercise, the main instructor asks you read more on quotational data or time series data and panel data. Please, let's do more. Let's do and read on it so that in the next class we can have an interactive section. Thank you.
Thank you.
Thank you very much.
Okay. All right. Do have a great day, all. We'll see you in the next class.
Right.